Elements often exist in what's called an allotrope, which means it's the same element but different forms. And carbon is by far the best example of this. Now, probably you've all used graphite, which is the main ingredient of pencils, all right? It's like the lead. It's not lead at all. It's graphite, all right? But people call it lead. It's all right. It kind of bugs me as a chemist, but I'm not going to hold it against anybody. Anyway, graphite is a form of carbon. And if you look at that animation, there's like sheets of carbon atoms, and those sheets kind of wear off when you use the pencil and stay on the paper, which is kind of cool. Now, graphite is really cheap. You can go buy 100 pencils for almost nothing. Diamond, on the other hand, the one below it, is also carbon, but look at how it's rearranged. That's a three-dimensional structure. Diamond is quite different than carbon. Both of those are carbon atoms. All those little black atoms are carbon, but diamond is incredibly tough. And diamond, as you know, is also really expensive. It's very rare. It can be used for industry, for cutting things. It's one of the hardest substances known. So graphite and diamond are very common forms of carbon, but quite different, all right? Once in a while, Superman will like squeeze charcoal, which is basically graphite, and make diamonds out of it and stuff. So if you're a Superman fan, cool. And if you don't, you've better things to do with your time, obviously. Now, the one on the bottom is a relatively newer player. It's called Buckyball. The official name is Buckminster fullerene. Long story behind that. But anyway, that's the C60 thing. That's a third version, a third allotrope of carbon, all right? And it's really cool. Buckminster fullerene was named after this guy named Buckminster Fuller, who's really interesting. And also, there's other forms of carbon as well. Graphene is one of them that's really interesting. So all of these are carbon, but they're different forms of carbon. And you can probably imagine that reacting graphite is going to be a lot different sometimes than reacting diamond. So elements can have more than one allotrope, which means more than one version of the same element. Most of the elements, though, just exist as single individual atoms. So, for example, sodium and magnesium and things like that, just single. However, there are 7 elements that exist always as diatomics. So, di is 2, 2-atomed. All of these elements exist in pairs. And I like this little phrase right here, have no fear of ice clear brew. And it can be root brew. It doesn't have to be anything else, all right, if you're under 21 or 19 in Canada. But anyway, have no fear of ice clear brew is important because these seven elements that I've highlighted there in red exist as diatomic. Now, almost all the other atoms on the periodic table you can think of as monatomic individuals, but not these 7. So when it comes to hydrogen, nitrogen, fluorine, oxygen, iodine, chlorine, and bromine, all of those exist as diatomics, 2 of them. So that's where the have no fear of ice clear brew thing shows up. Now, some people like using the expression honkel briff, which is in the kind of star right there, and that's fine. And there's several other sayings like this, but these 7 diatomics are going to be really important to us in the next section. So hang on to this piece of knowledge. These are going to come back. Again, I want to repeat, though, most of the elements on the periodic table exist as single pieces. So if the element is not on there, then more likely than not, it's a single atom. So as I said, magnesium and sodium and helium and xenon, all right, all of those are not have no fear of ice clear brew. So you don't have to worry about it. But if you are dealing with oxygen or bromine, then you've got to think about it as a diatomic. There are other elements that exist in more than one piece. Phosphorus is a great example of that. Phosphorus, there's white phosphorus, red phosphorus, and even a black phosphorus. All of those are different forms, and you can see what they kind of look like right there. Sulfur exists in what's called an octamer, which is 8 atoms. And ozone, which is O3, 3 oxygens, is also another form of the elements with more than one. So you can see it's kind of interesting, but I do want to highlight most of the time the elements are just single atoms. But if you get to the have no fear of ice clear brew, then you have to remember those are pairs. Don't worry so much about phosphorus, sulfur, or even ozone for that matter. If you know the 7 diatomics and the fact that almost all the other ones are single ones, you'll be good to go.